Today, we're going to be looking at analyzing ionic attractions. So, how do elements come together and form an ionic attraction? We're going to start with analyzing a couple of diagrams. So, let's go ahead and just see what we can identify in this first diagram. So, we have Na, which we know is sodium, and Cl, which we know is chlorine. We have Bohr models for both of them. We have the dots for chlorine representing electrons and the X's for sodium also being electrons. And we see that the reason for that must be on this side. So we need to be able to determine whose electron belongs to who. So we also see an arrow, so something jumping and moving. On the other side, we see Na plus and a Cl minus. So now we have a charge, or we have something indicating a change in charge. We also see that sodium has only 2 energy levels versus 3 where it started. Its electron jumped to chlorine. We see that over here. And we also see that these are now stuck together or super close together. So the first thing we want to do is look at number 1 and number 2 and just start filling out our table and seeing what we can identify and where things come from. So the names of our elements, well, we know we have sodium and we have chlorine. Sodium is a metal because it is to the left of the staircase. Chlorine is a non-metal. It is to the right of the staircase. Total number of electrons. Okay, well, there's 2 ways we could figure this out. We could just count them, or we could look at the atomic number. So sodium's atomic number is 11. So it has 11 total electrons, where chlorine's total electrons is 17 because its atomic number is 17, or we can count the dots. Number of electrons in outer shell. So remember that outer shell, what we're talking about here are the valence electrons. So sodium has 1 valence electron, it's in group 1a, and chlorine has 7 valence electrons, it's in group 7a. So now let's see if we can figure out what this plus and this minus means and where it comes from, okay? Because on this side we don't have it, and on this side we do. So let's think about this. The only thing that has charges in our atom are protons and electrons. Protons are positive and electrons are negative. So that must be what's going on here. There must be something changing to give us a plus and a minus for our overall atom. So let's figure that out. Sodium over here, I'm going to identify how many protons and how many electrons it has. So sodium's atomic number is 11. So we know it's that top number, and that tells us how many protons and electrons there are in a neutral atom. So here, sodium has 11 protons, which is a positive charge, and it has 11 electrons, which is a negative charge. So a positive 11 and a negative 11, if I add those together, give me 0. Okay, well, that makes sense because we don't see anything on the symbol. There's nothing to indicate that it's anything but neutral. Let's do the same thing for chlorine. So chlorine has 17 protons, and it has 17 electrons here, and as a neutral atom. So if I add those together, 17 plus with 17 minus is 0. Again, chlorine here is neutral, but we know that it's not on the right-hand side. So let's figure this out. For the protons, sodium still has 11 protons. We haven't changed what element it is. Remember, if you change the element, then you're changing your number of protons. But for our electrons, instead of 11, one of those jumped and went to chlorine, and we see that here. So now sodium has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. So 11 positives with 10 negatives is a 1 positive. Okay, well, that 1 positive is what we see here as our plus, indicating a positive, meaning there's 1 more proton than there are electrons. Let's do the same thing for chlorine and see if we get a negative. So chlorine still has 17 protons because it's still chlorine, so that's the proton number. For electrons, though, we had 17, but we gained 1, which came from sodium. So now there's 17, 18 electrons. So 17 plus and an 18 minus. You add those together and you get 1 minus. Well, that must be where this minus is coming from. So we now know that our charges, meaning the symbols in the upper right-hand corner, is how many extra protons or electrons there are in comparison to it being neutral. So now we know that sodium has 1 less electron and chlorine has 1 more electron. And since the proton number doesn't change, we're talking solely about electrons. Okay, also, just like with magnets, positives and negatives, there's an electrostatic attraction between them. So they pull it in closer together and they stick together. So let's sum it up and describe what's happening in this diagram. So sodium is giving an electron to chlorine. And then sodium lost its outermost energy level. And we see that here going from 1, 2, 3 to now going to 2. And I do want to point out that we have that 1 on the third, and now on the second energy level, which now becomes its valence shell, it has 1, 2, 3, 4, 5, 6, 7, 8, while chlorine on its valence shell has 1, 2, 3, 4, 5, 6, 7, 8, also has 8. So then how do the reactants on the left side of the arrow change when they become products on the right side of the arrow? Well, sodium lost an electron and became positive. And we saw that because the number of protons stayed the same, but now we have 1 less electron, so that's how we got a positive 1. While chlorine gained an electron and became negative. And we see that again because there's 1 more electron than proton, so it has a -1 charge. Okay, now that we did this first one, let's look at the second one. And straight away, we can see that there's a lot of things that are similar, and there are a couple of things that are different. We still have 2 elements, and here they're being added together, essentially, meaning they're being reacted and combined. And we have magnesium and oxygen. We see energy levels, we see electrons, we see the X's representing electrons from magnesium. But instead of 1 jumping, we have 2 jumping. So now instead of 1 electron moving, there are 2. And on the right-hand side, we see there's still charges, but now it's 2 plus and 2 minus. So let's start filling in our chart and see where those pluses and those minuses come from. So our first element is magnesium. Mg is for magnesium. Our second element is oxygen. O is for oxygen. The magnesium is a metal because it's to the left of the staircase, and our oxygen is a non-metal. It's to the right of the staircase. And that's curious because when we looked at sodium and chlorine, it was a metal and a non-metal. And now we have magnesium and oxygen, which is a metal and a non-metal. I think there might be a pattern here. Total number of electrons. Well, magnesium's atomic number is 12. We could also count the X's, and it will tell us 12. Oxygen has 8 total electrons. Its atomic number is 8, or we can count the dots. Number of electrons in the outer shell. So remember, we're talking about the valence shell here. So magnesium has 2, 1, 2, and oxygen has 6. 1, 2, 3, 4, 5, 6. Okay, so now let's figure out our protons and our electrons so we can see where this 2 plus and 2 minus comes from. So let's start with magnesium. So magnesium, as a neutral element, has 12 protons, because that's its atomic number, and right now has 12 electrons. So 12 plus and a 12 minus is 0. So we don't see any charge on the upper right-hand corner. Oxygen has 8 protons because its atomic number is 8, and it has 8 electrons. So +8 and a -8 added together is 0. And we see that again as a neutral element with no charge. It's just a symbol. On the right-hand side, it's still 12 protons for magnesium because it's still magnesium. Remember, if you change the protons, you change the element. But now for electrons, it only has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It only has 10 negatives, 10 electrons, because 2 of them transferred from magnesium to oxygen. So a 12 plus and a 10 minus is a 2 plus. That is what we see as the charge in the upper right-hand corner. Oxygen still has 8 protons because it's oxygen, and that's its atomic number. But now it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. So an 8 plus and a 10 minus is 2 minus, and that's what we see here as our charge. So this is very similar to the first one we saw, and now we know where those pluses and those minuses come from. It's from gaining or losing electrons. Remember, we can't gain or lose protons because this is, we're not changing what element it is. We're just looking at the electrons transferring. And again, a positive and a negative, there's an electrostatic attraction between them, so it pulls it in closer and they stick together. So describe what's happening in this diagram. Well, we're going to follow the same kind of setup we did for the first question. So magnesium is giving 2 electrons to oxygen. And then magnesium lost its outermost energy level. And this is the same thing that happened with sodium in the first example. But I do want to point out again that over here on the right-hand side, after those 2 get transferred, magnesium has 8 in its outermost shell now, and oxygen also has 8 in its outermost shell. So then how do the reactants on the left side of the arrow change when they become products on the right side? Well, we're going to follow the same pattern we did for the first example. Magnesium lost 2 electrons and became positive with a 2 plus. While oxygen gained 2 electrons and became negative with a 2 minus. If you look on your next page, there is a third example that you're going to work on your own. So I want you to look at this third example, and you're going to follow the same thing that we did for the first 2, where you're filling out and describing what's going on in the diagram. You're counting up your protons and your electrons. Now this does look a little different. Instead of one element, one atom of each element, we have 2 atoms of lithium and 1 atom of oxygen. So here we have 1 electron going from lithium and 1 electron going from this lithium, both to oxygen. And that's what we see over here. So this is, it's very similar to what we saw before, but now instead of 1 atom from each element, we have a couple of them. So I want you to do the same thing that we did for the previous 2 examples for this third one, and be sure to answer this question right here, okay? When you get to the text, what you're going to do for the text on this page and in the next is annotate. So that means numbering our paragraphs, highlighting key concepts, circling key terms, defining words you don't know, writing mini summaries in the margins, asking critical questions, And then after you finish that, we'll move on into the Lewis dot structures.